Hey everyone, our final task for this particular quiz cycle is going to be to solve what are called compound inequalities. Now remember, a compound inequality is an inequality that comes in two parts. It's two parts smashed together. Just like a compound eye is an eye, like on an insect made from lots of little eyes put together. A compound sentence is multiple sentences joined together with a conjunction. A compound inequality is two inequalities, or more, put together. So the first thing we have to do, if we're going to solve these compound inequalities, and we solve them just like we solve regular inequalities, and just like we solve equations, but first what we have to do is separate the compound inequality into two regular inequalities. Then we can solve each part using the same techniques that we already know, and then at the end we'll put it back together to make a compound inequality. And most of what this video is just some examples to show you what that looks like. Here I have an OR type compound inequality. You can see the OR part of this right here. And so the first thing I'm going to do is separate this into two different inequalities. So I can see my two inequalities are separated by the word OR. Now I'm going to take my first one, b minus 1 is greater than 4, and solve this inequality. That means to get the b isolated by itself. So I'm going to add 1 to both sides. And I find that b is greater than or equal to 5. That part is solved, so now I'll come to the other side. Negative 7b is greater than 42. I want to, again, isolate the b, so I'm going to divide by negative 7. And this is an inequality, so when I divide by a negative number, I have to flip the direction of the inequality symbol. And then I have 42 divided by negative 7 would be negative 6. Now, my last step, I've solved it because I have this, and now I need to graph it. Ooh, I should be careful. I haven't solved it completely. I have to rewrite this as a compound inequality, which in this case is as simple as putting the word OR back in between them. So b is either greater than or equal to 5, or b is less than negative 6. Now I want to graph both of those. So for b is greater than or equal to 5, I can put a circle around 5. b, the shaded part, is larger than 5, so I will shade this way. But b could also be equal to 5, so I will close in the circle as well. b has to be less than negative 6, so I'm going to shade in all the portion less than negative 6. This matches our expectation for an OR statement because we've excluded this part in the middle. And we're talking about everything on either direction of that. So here's another example, this one using AND instead, and having slightly more complicated parts. Everything we know about solving equations and inequalities is still true on this. So the two inequalities that make up our compound inequality can be as complex as we'd like. Here I've got 5a minus 2 is greater than or equal to negative 12. I'm going to isolate the a, so the first thing I have to do is add 2 to both sides, which tells me that 5a is greater than or equal to, these cancel, negative 10. Now I'm going to divide by 5 to isolate the a, these 5's cancel, and I find that a is greater than or equal to negative 2. I divided by a positive number, so I do not have to flip the direction of the inequality. Now I can move to my second inequality. 10a plus 10 is less than 40, and we can solve this one in the exact same manner. So I subtract 10 from both sides. 10a must be less than 30. Divide both sides by 10, and I find that a must be less than 3. And if I put these together with an AND, just like they had between them before, I now have my compound inequality as an answer. So that is solving it. Now I have to graph. A is greater than or equal to -2. So I'm going to be shading in this direction. And it has to be a closed circle because it can be equal to. And then A is less than 3, so I want to shade everything less than that. And here you can see that this makes our usual expectation for an AND statement, talking about the space in between two numbers. So those have been pretty simple. Both of them involve AND or statements, so it's pretty straightforward to divide the inequality up into two parts. When the compound inequality is written like this, however, it's not nearly as obvious what those different parts are. So I'm going to use some color to help us separate out in example 3 what our two inequalities are. So always start on the left, go until you see your first inequality symbol, take what's on the other side of that, and then stop when you get to the other inequality symbol. And everything that I've put in that box now is one of our two inequalities. So I can write down 18 is less than or equal to 8n plus 10. And now I solve that just like I know how to. There's no mystery here. Subtract 10 from both sides. 8 is less than or equal to 8n. Divide both sides by 8. And I find that 1 has to be less than or equal to n. Now, I need to find the second part of my inequality. The way that I do this is to take, starting again from the left, past the first inequality, and then take all the rest of it. So notice that middle part gets used twice. Excuse me. Once with the left half and once with the right half. So my second inequality would be 8n plus 10 is less than 42. And now I solve that just as I've solved the others. I find that 8n is less than 32. Divide both sides by 8. And n is going to be less than 4. Now I want to graph these. I'll graph them both in red. For n is greater than or equal to 1, so I'll put my circle around 1. And I know that I want n, my shaded portion, to be greater than that, but also could be equal to that, so I'll fill in the circle. For n is less than 4, I know I want everything less than 4. There it is right there. And so you can see this is an AND statement, and I'm looking at the part in between. So everything between 1 and 4, and including 1, will be a solution to this inequality. We can check that by substituting back in. If I replace the n with a 2, I would have 18 is less than or equal to, well, 2 times 8 is 16. 16 plus 10 is 26. And I can see that this is true. 18 is less than 26, and 26 is less than 42. So all of this checks out. Let's look at another example. I'll again divide this up using red ink for the first part and blue ink for our second part of the inequality. And now I just take each individual part and solve it as if it were all by itself. So I'm going to subtract 10 from both. I get negative 18 less than 2v. And now I need to divide both sides by 2. And I find that negative 9 is less than v. For my blue side, I have 10 plus 2v is less than 12. So I would subtract 10 from both sides. Notice how similar this is to what I was doing before. That first move, subtracting 10, was the same on both. That's not an accident. That will happen. Now I divide by 2, and I find that v must be less than 1. When I go to graph this, I have at -9 a circle. V has to be bigger than 9, so we'll go this way. Over here, v must be less than 1, and so we would shade to this part, and we can see our AND statement pop out of this. Now, one thing I neglected to do on the last problem, and I really should have, my apologies, is to rewrite this whole thing as a compound inequality. Now, there are two ways I can do this. Looking at the graph, I now see this as an AND statement, so I can do it like that. There is nothing wrong with that. That is technically correct. But since this compound inequality was presented in this format, we should probably keep that format when presenting our answer. So to write this, I would simply write your bottom one, your variable, and then your higher number, so lowest number, variable, highest number. We know that our variable, our shaded region, has to be bigger than our smallest number, and in this case it's less than our bigger number, and so that right there would be our compound inequality. Let's look at one more. This is as mean and as nasty and as ugly and hateful as these can possibly get, so if you know what's going on here, then my friend, you are in good shape. I define my two inequalities. There's one and there's the other. Notice there are variables in all three parts of this inequality, so I'm going to have variables coming out my ears while I work this, and that's quite all right. I rewrite my first inequality. I check for any distributive property. There is none. I check for any combining like terms. I can't do that, but I do have variables on both sides, so I want to gather them to one side. So what I'll do is I'll get rid of the x over here by adding an x to both sides. That gives me -6 is, -6 plus 4x is less than -2. Now to isolate the x, I'm going to add 6 to both sides so that I have 4x is less than 4. Divide both sides by 4, and my answer comes out to be that x is less than 1. Now I have to repeat for my blue side. -x minus 2 is less than 4 plus x. There's no distributive property, there's no combining like terms, but boy howdy, there are variables on both sides. I'm going to get rid of this minus x by adding an x to both sides, leaving me with -2 is less than 4 plus now 2x. So subtract 4 from both sides. I find that -6 is less than 2x. Divide both sides by 2. Moving quick here, I realize. And I'm left with that. So now I need to graph these. So I'm going to say that x is less than 1. So that's going to go this direction. And over here I see that x is bigger than -3. And so this is going to be an AND statement. When I'm rewriting the answer to this, I could then put my two solutions together with the word AND. However, since this was presented in this format, maybe we should keep that format. Lowest variable, x, or lowest number, variable, and then my highest number. I look at the -3 and the x has to be bigger. I look at the x and the 1 has to be bigger. And so here is my answer written as a compound inequality. So when we're solving these compound inequalities, divide it up into 2, solve each individually, and then recombine them back into a compound inequality. Good luck.